Okay, in this video we're going to talk about trigonometry and review some of the trig functions that are useful in solving physics problems. First of all, the trigonometry is the study of right triangles. So if I draw a right triangle is any triangle with a 90-degree angle. Some terms that we need to be aware of with these right triangles are the following. So you need to know the longest side of a right triangle is called the hypotenuse. And if we're studying this angle here, we call it theta. It's a Greek letter. They always use this symbol for the degree, or the angle degree. The side opposite of this angle is called the opposite side. So I'll just abbreviate it with an O. And the side closest to theta is always called the adjacent. So I'm going to write an A. And so hypotenuse is always the longest side. Adjacent is the side closest to the angle you're studying, and opposite is opposite the angle. And then one of the most useful mnemonics in trigonometry is this one, SOHCAHTOA. So if you remember SOHCAHTOA, it's very useful, and what it stands for is sine of theta is equal to opposite over hypotenuse. So opposite divided by the hypotenuse. And so let me switch colors here. Cosine is what the C stands for here. So cosine of theta is equal to the adjacent side. So adjacent divided by the hypotenuse. Okay, and then finally the last one, TOA, what it stands for is tangent of theta is equal to O, which is opposite, divided by A, which is adjacent. And so if you ever get confused about what the trig functions mean, remember SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. There's two reasons why we use the trig functions. The first reason that we use the trig functions is to find an unknown side. But if you don't know one of the sides, you must know at least one other angle besides the right angle and another side. The second reason we use the trig functions is to find an angle. But if you need to find an angle, you have to know at least two sides of your triangle. So we're going to go through a few practice problems and go through all the different scenarios that you're going to see with these trig functions. In this first practice problem, if we look here, we've got an angle of 60 degrees inside this right triangle. We know it's a right triangle, so you usually see this little box here that tells you this angle is 90 degrees. So we've got an angle of 60 degrees, and we notice that we have a side that's closest to this angle of 3 meters, and it wants us to find x. X in this case is the longest side, so this is your hypotenuse. So if we remember our mnemonic, SOHCAHTOA. So if we remember our mnemonic, SOHCAHTOA, now we're going to try and figure out which of the trig functions to use for this triangle. We have the side closest, which is the adjacent side, and we want to know the hypotenuse. So which one of our trig functions has adjacent and hypotenuse with it? And adjacent and hypotenuse you're going to see right here with ka. So what that means is cosine of your angle, 60 degrees, is equal to the adjacent side, which was 3 meters, so I'm just going to put 3, divided by the hypotenuse, which is x. And so now we just have an equation with one unknown. We're just going to solve for x. So to simplify it, we're going to times both sides by x. So we got x cosine of 60 is equal to 3. Now we want x by itself, so we divide each side by cosine of 60, and you'll find that x is equal to 3 divided by cosine of 60. And now you just get your calculator. One hint here, and it's always important to remember, is that you put parentheses around your trig function and you'll make less mistakes with your calculator. So get my calculator, so 3 divided by parentheses cosine, so 3 divided by parentheses cosine of 60, and then close it off with your parentheses, and I'm finding that x is equal to exactly 6, and so that will be our answer here. And they're measuring the length in meters, so I guess we should put 6 meters would be the length of this side. And that makes sense. If you go back, it's always a good idea to make sure that the answer that you get makes sense. And our one side was 3 meters. Our hypotenuse is always the longest, so a hypotenuse of 6 meters in this case seems reasonable. All right, practice problem number 2. We have an angle of 30 degrees, so theta is equal to 30 degrees, and we have a side that's directly opposite that angle, and we have the hypotenuse again. So our hypotenuse is always opposite your 90-degree angle. So if we remember our mnemonic, so toa. So we're looking for which trig function to use when we have an opposite and the hypotenuse. So opposite and hypotenuse, and you're going to notice it's this first one. So sine of 30, because that's our angle, sine of 30 degrees is equal to the opposite side, which was 250, divided by the hypotenuse, which was our x. We don't know. Okay, so when we solve for x, it's going to look like this. X sine of 30 is equal to 250. Again, divide each side by 30, and we'll be left with x is equal to 250 divided by the sine of 30. Again, put parentheses around your trig functions and you'll make less calculator errors. So I grab my calculator, 250 divided by parentheses sine of 30, and what I'm getting is x is equal to 500. And our units again are in meters, so I'll put meters. And so let's go back and look at it and see if it makes sense. So if x is equal to 500, would this seem logical? And that's our hypotenuse, so it's got to be the longest side, and it's twice as long as this side, so it seems logical. Okay, practice problem number 3. We have an angle of 60 degrees down here now, and we have from that 60 degrees we have x, which is opposite of that, and we also have a length of this side, which is 100 meters, which is the closest one, so adjacent. So again, remember, SOHCAHTOA, and what we're looking for is something with opposite and adjacent in it. Opposite and adjacent. And we notice that the first two have hypotenuse, so we don't have a hypotenuse, we have an opposite over adjacent, and so we're going to use tangent in this case. So tangent of 60 degrees, because that's our angle, is equal to the opposite, which is x, divided by the adjacent side, which was 100. And so when we solve for x here, we're just going to have to take 100 and times it by both sides, so we get 100 tangent of 60 is equal to x. And again, I always like to put parentheses around your trig function. So 100, get my calculator, times parentheses the tangent of 60, and I'm getting, if we just round to one decimal place, that x is equal to 173.5 0.2. And our units again were in meters, so I'll put meters here. So there's our answer. And let's go back to the triangle and see if it makes reasonable sense to us. So if this side is 173.2, and that seems like it's logical because this is a longer side than our 100 meter side down here. And so it seems reasonable. Alright, practice problem number 4 is a little bit different. Now this time we have an unknown angle that we just call theta, and we have a side closest to it, and we have the hypotenuse. And so when we look at our SOHCAHTOA, we're looking for one that's adjacent and hypotenuse. And so adjacent and hypotenuse, and it looks like we could use this middle one, ka. So cosine, and now we don't have the angle, so I'm just going to keep calling it theta. And cosine of theta is equal to the adjacent, which is 50, divided by the hypotenuse, in this case was 150. Alright, now when you get to this point, we're going to treat theta as x, and so we're just trying to isolate theta and get it by itself. And the only way to do that is what's called the inverse cosine. And if you take the inverse cosine, so theta is going to be equal to cosine to the minus 1 times 50 over 150. Oops. And so on your calculator, to find the inverse cosine button, it's always you have to hit the second function, and then if you hit cosine, you'll notice there's a little cosine with the minus 1 sign above it. And so I'm just going to hit second function cosine, parentheses, 50 divided by 150. And then close it off with your parentheses. And I'm getting that theta is equal to 70, if we just round to 1 decimal point again, 70.5. And so 70.5 degree angle here. And that seems like it could be logical there, so we'll keep that. So 70.5 is what our angle turned out to be there. Okay, one more problem. If we look at practice problem number 5, again we have an unknown angle, so we had to know two sides. And it looks like our sides are opposite theta and closest to theta, so opposite and adjacent. So if we look at SOHCAHTOA again, we have opposite and adjacent. So we're looking for opposite and adjacent. You're going to see it right here. So tangent of theta, that's the angle we don't know, is equal to the opposite of that, which is 25, divided by the adjacent, which was 40. Okay, and again, to solve for theta, we just treat it like x. The only way to get it by itself is to take the inverse tangent. So theta is going to be equal to tangent to the minus 1 times 25 divided by 40. And so again, the inverse tangent would be this. You have to hit the second function on your calculator, so second function, and then hit the tangent button, and you'll notice a little tangent to the minus 1 sign. Parentheses 25 divided by 40. Close your parentheses off, and I'm getting that theta is equal to 32. If we round to 1 decimal point, it's just 32.0. So 32.0 degrees, and that makes sense. So what I've got for you now with your video physics assignments is just 5 questions, very similar to the ones that we have just gone through. So if you get confused on any of the upcoming problems, remember you can always go back in the video, watch it and review it, and see if we can get these down. If you're still having problems with some of the trig functions and these problems, feel free to stop by at any time, and we'll figure it out. But good luck. I'll scroll through them slowly so that you'll have time to pause your video and solve the problem and then just move on. So there'll be 5 questions coming up.